Alright, here's the most important stuff we need to learn about composite functions, and that is finding the domain of composite functions. Okay, here's the thing. If you find, when you're finding the domain, of F composite G, for example, you must consider both the domain of G of X and the domain of F of G of X, but not the domain of F of X. Okay, since we have to plug into function G first in this situation, we can only plug in X values into function G that actually are part of that domain. We can't plug something into function G that won't exist in function G. Then, we also have to make sure that our final answer function has to be something that X can be plugged into, or it's also not going to be in the domain. But we're never, in this situation, never actually going to do F of X by itself. So we don't care about what the domain of just plain old F is, because we will never actually have to deal with that. We're only considering the fact that we're limited by what we can plug into G, and then also limited by what can be plugged into the final answer. Let's look at a couple of examples. Find the domain. I hope I'm talking loud enough. Okay, find the domain if f of x is 2 over x minus 3 and g of x is 1 over x plus 4. Okay, so in this problem we're plugging g into f. So the first thing we have to look at is the domain of g of x, because we have to realize what we can actually plug into that in the first place. So it looks like x cannot equal -4. So since g of x is the first thing we have to do, and we can't plug in a -4, that means -4 cannot be part of our domain for this problem, ever, because we can't plug it into the first function. Okay? Now what we do is we actually find f of g of x. What that means is we take this function and plug it into the x in this function. So we find f of g of x, or in other words, we plug 1 over x plus 4 in place of the x there. Well, we don't want to have fractions in fractions, so we need to get a common denominator. So let's do this in a different color. Common denominator here will be x plus 4 over x plus 4, therefore we're multiplying this fraction by 1, we're not changing its value. So we'll have 2 on the top of our fraction still, and then here we'll have 1 minus 3 times x and minus 12. Here, we better write that out. So this will simplify to -3x minus 11 once we combine those together, right? Now to get rid of a fraction in a fraction, we usually think of it as dividing fractions. And when you divide fractions, you copy the top fraction, which in this case is just a number. So if we wanted to, we could turn our fraction, our 2 into a fraction 2 over 1. So we copy the top fraction. We realize that we're going to multiply, and then we flip the bottom fraction. so that we're multiplying by the reciprocal, and that's how we divide fractions, is by multiplying reciprocals. So we're going to flip this one over so that we'll have x plus 4 on the top and negative 3x minus 11 on the bottom. And so then we multiply across, so we'll have 2x plus 8 and negative 3x minus 11. That should be our composite function. Okay. Now we want to look at the domain. Well, the domain is looking at what that denominator can't be. So this one was easy to look at and just say, oh, it can't be negative 4. This one's a little bit trickier. Probably easiest done if we take this thing, negative 3x minus 11, and set it equal to 0, and that's what it can't be, right? So negative 3x can't equal 11, and therefore x cannot equal negative 11/3. Okay, so our final answer for our domain then would be x cannot equal negative 4 and cannot equal negative 11/3, because we've had to consider both what we can't plug into g and also what we can't plug into f of g of x. But notice how we didn't care about the fact that we can't plug a 3 into f of x, because that does not affect our overall problem. We're never actually doing this. To begin with, we have to deal with this, so we can't plug in negative 4. And then later, after we've combined the fractions, the functions together, it just so happens that this makes it undefined when it's all said and done. But 3 is never going to be a problem. We can plug a 3 in here and get a 7. We can plug a 3 in here and get some other number on the bottom that doesn't make it 0. So 3 is a perfectly fine number for the domain, even though it would not be in the domain of f of x. This isn't plain old f of x. It's a composite function.